Hello everyone, welcome to today's live stream. Today we'll be discussing about the post-launch coverage of the Chang'e 5 mission that launched today at 7 a.m. Malaysian time. I will be your host for today. My name is David, and our panelists are Lai Hong Jun, our PhD student, and Dr. Zhong Hun Yu, which is our ASP's chairman.
So maybe we start with a short video.
Yes.
Shall we?
Sure, live please.
Yeah. So this is a very simple video to show on how the whole mission is about lah. So I share now. Can you all see my screen?
Can?
Yeah.
Okay. So I will play now. So this is actually in aerial view of this Hainan Wenchang Launch Center. Okay, so it's bringing this Long March 5. Okay, this is a special site built for Long March 5 rocket to be launched. And as we know, we don't have other place can launch this huge rocket. And then the launch, it starts from the launch, and then the launch, after the launch, then the satellite or the Chang'e 5, okay, separate from the rocket, goes to the transfer orbit and then the moon orbit, and then the lander, okay, detached from the whole Chang'e 5 module. The lander will land on the moon surface, all right, land on the moon surface. A soft landing, they are very experienced with this, no problem, all right. Should be no problem this time, but we don't know sometimes. And then they will take back the soil sample, the rock sample, all right, and then store it in the lifter, and then go back up, meet with the orbiter module, all right, and then the orbiter module will bring the whole thing back, right? Will bring the sample back to the Earth, okay. So come back to the Earth, and then it's about 500 kilometers away from Earth. Then they will release the lander, all right. The lander coming back, and then at about 10 kilometers, parachute deploy, and then we collect back the rock sample. So this is about a simple animation about the whole video. All right, so I think I will start the presentation now.
Yes.
And then after that, Dr. Chong, I will pass over to Dr. Chong. Is it okay?
Sure.
Okay, so let's start with a simple slides. Photo. Can see this photo, huh?
Yes.
Okay, so this is actually the logo of the whole China lunar exploration mission. So this is a Chinese word called Yue. Yue means moon, moon. All right. So actually this logo carries a lot of meaning. All right. It's an old writing of Yue, of Chinese Yue. Okay, it's an old writing which means represents since the ancient time of China, they have a lot of interest, and they are curious about the moon. Until today, we have this moon or lunar exploration project. And the blue outline over here, this blue one, okay, this blue stroke, all right, it's actually a simplified drawing of dragon. They said it looks like a dragon. So this is the dragon head and then the tail. All right, so this is the dragon, represents the Chinese, all right, 就是中华民族啊，龙是中华民族的图腾啊。And then the tail, and the tail over here, all right, this white thing, all right, is actually pigeon, represent peace. That means China is hoping that we explore the space we explore space, or we do space exploration together in a peace manner. It means we love peace. Okay, we share the space peacefully. And then there are two strokes. These two strokes is actually two footprint. Okay, represents the determination of these Chinese people to go onto moon, to land on moon, and then the human for human mission to land on moon. So these two 脚印 footprint represents 就是探月的决心。So this is the whole logo, and this logo we have it I think since 2007 when they start the project. So this is the whole logo of the whole mission. So this is the first one. Second one, all right, we have a look on the history of this Chang'e mission. All right, the first one, of course, we know in the year 2007 when we have the Chang'e 1, it's an orbiter mission. The whole mission is quite simple. We send a satellite or orbiter, lunar exploration module orbiter. We send to the moon, orbiting the moon, and then take back, capture some pictures of the whole moon. All right, of the whole moon. After 3 years, at October 2010, the Chang'e 2 is basically having the same mission with Chang'e 1. All right, but then slightly difference is this time, all right, they improve the camera, they improve the antenna system, they create some experiment. So in this Chang'e 2, all right, they claim that they have helped or they have held the record of getting the highest resolution Earth image. Sorry, not Earth image, moon image, which can up to 7 meters. All right, the resolution up to 7 meters. And then after that, in year 2013, the Chang'e 3, which carries the lander, the rover, lunar rover, the Yutu-1, which ended the mission 2 years back in 2018. Chang'e 3, and then after Chang'e 3, before Chang'e 4, they actually launched another mission in 2014. Previously, they actually called the Chang'e 5, but after that, they call it Chang'e 5T1. That means trial 1, just to simply send the whole satellite go to the moon orbit the moon, and then come back to Earth. The intention is to try the landing module. All right, because what's special about it is they are re-entering the Earth at a very high velocity. It's actually at the escape velocity of Earth. And then a few years later, actually, it seems like it stopped for some time. And a few years later, which is 2018, 2 years back, only they launched the Chang'e 4, which is currently still working on the far side of the moon, the rover, the Yutu-2 rover, Yutu-2 at the South Pole, far side of the moon. And until today, this morning, 4:30 a.m., morning 4:30, they launched the Chang'e 5. So this Chang'e 5 is actually the third step of the first plan. There are 3 stages. There are three stages of the whole China lunar mission. The first stage is we call it Tan. Tan, that means explore. In the first stage, we have 3 steps. So now it's at the third step of the first stage. The second stage is Teng. Teng, that means we are going to land on the moon with human being, right? So Tan, the first stage is Tan, second stage is Teng, third stage is Zhu. Zhu, that means stay for a longer period on moon. So there are 3 stages. So currently we are in the first stage. First stage, there are 3 steps. Rao, that means orbiting. Second is Luo, that means landing. And the third step is Hui, that means return. So this is the first project of Hui, which is send this Chang'e 5, land on the moon, collect some sample, and then coming back to Earth. So this is the whole overview of the history of this Chang'e project, or the whole the China Lunar Exploration Project. So next, we proceed to the next one. So this is the rocket that used for the launch. Okay, if you all can see. So it's a double-stage rocket. This is the 5th launch of Changzheng 5, Changzheng 5号, the 5th launch of the original model. There are 2 variants. One is Changzheng 5A, or the original Changzheng 5. Another one we call it Changzheng 5号 That means Chang'e 5B or CZ 5B. So this is the original one. So there are two-stage rocket with 4 boosters. All right, so there are 4 boosters. And this rocket, I think in previous session on the Mars mission, when we talk about the Tianwen, we already give some details explanation about rocket. So I will go through briefly. So this is a clean and green rocket and also powerful. So why is clean now and why is green? Because the fuel is hydrogen, the oxidizer is oxygen. So oxygen and hydrogen, the product end up is water. So it's clean, no pollution. All right. Different from the previous Chang'e CZ2 or CZ3, they carried this UDMH, which is toxic, cause pollution to the environment. So this time we are going green, going clean. So we are very environmental conscious this time. So we have clean rocket. All right. So we have the byproducts is water. And also this is a very powerful rocket. And this is the largest rocket currently China have. All right. The diameter is 5 meters. So it can carry this extra huge satellite. All right. And we are going to launch this they have launched a lot of mission with using this rocket for Mars mission, and also in future the China Space Station mission they were launching using this Chang'e 5 and also another module called the Chang'e 7. So this is the rocket. So over here there's this number 12. Number 12 is hydrogen tank. Up here is the oxygen tank. So because the byproduct is water, we know water, the molecular compound is H2O. That means 2 hydrogen atom and 1 oxygen atom. So the hydrogen will consume more compared to this oxygen. So eventually they will have a bigger hydrogen tank than an oxygen tank. And it's a liquid rocket. So that means inside is liquid hydrogen and liquid oxygen. All right, it's liquid stage. So the whole rocket is very cold. The temperature is very low. So they also call it ice rocket. In Chinese, they call it 冰箭, because it's very low. We use low temperature fuel. All right, so let's see what we have next. Okay, this is the launch site. So a simple introduction about this Hainan Wenchang satellite launch site. So there are two. Okay, there are two, we call it two assembly line. All right. So the one on the right, this one is for Chang'e 5, and the one on the left, this one is for Chang'e 7. So in this Hainan Wenchang, we only launched 2 rockets. One is Chang'e 5, another one is Chang'e 7. So only 2 rockets. So the assembly is conducted over here. So after they finish assembly the rocket, they will not do the refueling over here. All right. So after finish assembly, and then they will push the rocket out. So over here, they will send it to the Gantry Tower, which is the launch pad. The whole launch pad will travel about 3.5 kilometer distance from this assembly line to the launch site. So there's actually 2 tracks. All right. So we say this is the most expensive car in the world. This over here, this base and this tiang over here, right, is the most expensive car. Carry the rocket, okay, it's about 200 million for the cost of this vehicle. All right, it's the most expensive car, and it's expensive, but the speed is very low. Maximum speed is 1.8 kilometer per hour. That means 30 meter per minute. So the time taken to travel from this assembly line to the launch site is actually about almost 2 hours. Okay, so from here they proceed, we go, and then we will go next place. Travel to the launch pad, the Gantry Tower. Oh, here this is the Gantry Tower. So this is the place where after the rocket is transferred to this launch site, it actually means that we already start the countdown for launching. All right, so they will start refueling, they will start all the final check, the cross check over here. Okay, so usually from transfer the rocket from the assembly line to gantry over here to the launch time is about usually not more than 1 week unless the launch is aborted. All right. So next. So this is about the whole Chang'e 5, the spacecraft Chang'e 5. All right. So over here, when it launched, it's all together. All right. So we have orbital mission, and then the orbital mission will carry the lander, and then we have this. This is the Earth lander. That means the return mission will return to the Earth. This is a lander for Earth. This is the lander for Moon. All right. And this is the, I'll translate it as the lifter. In Chinese, we call it 上升器, and it will deploy, it will take off from the moon surface. All right, take off from moon surface back to Earth. So this is what we see, the drawing. Okay, and then on this lander, the lunar lander, there are actually 6 payload. There are actually 6 payload. All right, one is the landing camera located at the bottom of the lander. All right, landing camera, and then one is the 360-degree rotatable camera to take the panoramic view of the moon. So it's somewhere up here. Okay, and then we have this camera is located on a 360-degree rotatable platform. All right, so this is considered as 2 payload. And then we also have they call it the moon mineral spectroscopy. It means they have a spectrometer go up to take the line spectrum of the minerals of the moon. And also they have this moon soil structure detector to study the soil structure of the moon. And also they will bring up a flag display system. They call it flag display system. So previously, when we look at the Chang'e lander, or even if you happen to visit Tech Dome, you look at the Chang'e 3, Chang'e 3 model displayed in Tech Dome. You see the flag is like a sticker, or it's directly painted or pasted on the Chang'e 3 lander, and Chang'e 4 lander also the same. But this time, they did not print the flag on the surface. Right? So it's like a deploy system. So they will race out, and then they will show the flag. So it's something a bit special this time. So there are the 6 payload of the lander. All right, and then we proceed, see what we have next. So this is the landing spot. Okay, the landing spot of this Chang'e 4 lander. So they call it the landing area is called Monramkers, is it? Monramkers. And then land over here. All right, so nothing much. So if you all have a very powerful telescope, I think 4 days later, you all can try to look at the moon, focus at this point whether you all can catch this Chang'e 5 over there. All right, hopefully you all can see something over there. So nothing much about this. Let's proceed. So this is a whole, in publication we call it graphical abstract of the whole mission. Graphical abstract of the whole mission. So the rocket will bring the Chang'e 5. Chang'e 5, which consists of the 4 modules, to the Earth-Moon transfer orbit. 地月交接轨道 Earth-Moon transfer orbit. And then they will travel for 3 days, reach the moon orbit, and then the moon lander and the lifter, all right, will land on the moon surface. And then on the moon lander, there will be a drill to collect the soil sample. Okay, and then transfer it to the lifter. Okay, and then the lifter will take off from the moon surface. Okay, meet with the orbiter. All right, when the Chang'e 5, the whole Chang'e 5 reach the moon, only the lander and the lifter will land on the moon surface. The rest, which is the return mission and the orbiter mission, will continue to orbit on the moon. Okay, orbiting the moon. So the lifter will take off from the surface, the moon surface, to meet with the orbiter mission. Okay, after it meets the orbiter mission, it will do the docking and then transfer the soil sample into the Earth return module, All right, and then the orbiter mission and the return module will escape from the moon orbit. Okay, coming back to the Earth orbit, which is about 500 kilometers. 500 kilometers from Earth. They would separate. All right, the orbiter mission and the return mission will separate, leaving the orbiter mission to come back from Earth, come back to Earth. So to do the re-entry and then land on Inner Mongolia. All right, the usual place that all the space mission, Chinese space mission landing. All right, Inner Mongolia. So something interesting I'd like to say is the whole mission actually can be the beginning part of the whole mission from this takeoff to landing on the moon actually can be explained using this Newton's law, just to try to relate if we have young audience. All right, but before going to this, I just suddenly thought of something. Something very interesting is actually they say to understand this whole mission is very simple. It's like you order pizza delivery from the moon. How? That means this whole you call for this pizza delivery from the moon. So first, okay, we have to send the chef to the moon. So the chef is this drill to take the soil. So the soil, after they take the soil, so this soil is actually the pizza the done pizza. Okay, so this pizza will, after the chef have done the pizza, they will send to the reception, the counter. All right, so the waiter will take to the rider, which is the orbiter mission. So the rider will take your pizza and then put into this. They have this bag to store your, when you order pizza, they have this bag to store your pizza, right? So this return module is actually the bag to store your pizza. All right, and then when they reach near Earth, all right, 500 kilometers from Earth, that means they send this pizza is sent to Earth, so we collect from Earth's surface, which is this return module. So this is a very interesting way of presenting for kids how actually the whole mission is using something that we are familiar with. All right. So go back to something technical. Okay. I said that the whole mission actually we can explain in simple physics using this Newton's law. So we know Newton's famous with the three laws, right? The first is inertia, second is F equals to ma, and the third is reaction force. So the third law is very simple to be understand, because when we launch the rocket, it's actually the reaction force from the exhaust pushing the rocket up. So the Newton third law is used. And then the Newton first law about inertia is used is where? Which is at the second stage, right? If you all watch the live session of the whole live session of the launch, you all realize after the first stage detached from the second stage, when they start the second stage, after a short time, I think about 15 minutes, after 15 minutes of the launch, they actually close the second stage engine, and the whole second stage and the satellite or the spacecraft itself is allowed to glide for a certain period of time, and then before they transfer, they want to do the transfer of the Chang'e 5 into the Earth-Moon transfer orbit. Only that time they turn on the engine, the second stage again. So inertia, because in space we don't have this air resistance, so there's very minimum drag or we say close to zero drag in space. So the whole rocket second stage and the spacecraft will continue to travel at the initial velocity that they have before the second stage is closed down. So this is about inertia. And this F equals to ma, the second law, is actually the equation that we use for rocket. We call it the rocket equation calculation, or the derivation of rocket equation calculation. The whole physics is simple. The force generated, okay, that means we need the reaction force. So the reaction force or the force generated is actually the mass of exhaust, okay, the product of mass of exhaust and acceleration of the exhaust. Basically, we know that when we fire the rocket, that means we start the rocket, okay, before takeoff, all right, the flame, the exhaust, all right, is accelerating out from the nozzles. So the acceleration and the mass of the exhaust is actually the force. But this is a simple way. In fact, it's quite complicated, the calculation, so we don't go into details in this, all right. So next is about coming back. So coming back, this time coming back, all right. This is about something about returning for most of the spacecraft return mission, re-entry mission. So this is actually a simple trajectory drawn for missiles, but actually for re-entry spacecraft is also the same. All right. So you take off, go into the space, and then return. All right. So we call it the ballistic for ballistic missile. We send the missile up, or the rocket up. We go into the space and then re-entry, coming back. All right. So this is the traditional one, okay, which is designed by this father of aerospace in China, Professor Qian Xuesen. So it's named after him. Because this ballistic track is actually designed by him. But this time the re-entry is a bit different. We call it the stone skipping re-entry method. That means you throw the stone on the water surface, and then the stone will skip for something. Okay, I have some friends that are very good at this. I'm not good at this. So it's actually how it works is, but during the re-entry, all right, for this Chang'e 5 re-entry, it's like they're actually breaking the world record. Why? Because previously re-entry, the velocity is not that high. This time they are re-entry at the escape velocity of Earth, which is about 11.2 kilometers per second. So this is a very fast re-entry. So when they re-entry, all right, as they're coming nearer to the Earth, all right, the velocity is getting higher and higher, and of course they reach hypersonic. Hypersonic, which means the Mach number, which is they are traveling at faster than speed of sound for at least 5 times. All right, and based on the simulation, the re-entry Mach number might up to 40 or 50. Right, so this is a very high Mach number. So a lot of heat is generated, and for hypersonic flow, we know that it will, and the structure of this lander, it will have shock wave, and for different shock wave, there are actually different shapes. And for this shock wave, for the shape of this return module, lander Earth return module, all right, the shock wave form, based on the simulation, they will form a bow shock. And among the shape of shock wave, of course, the weakest one is this, we call it this expansion shock wave, and then followed by this oblique shock wave, and then normal shock wave, and then we have this the strongest shock wave with highest drag is actually this bow shock. It's actually a curved shock. It's a curved shock. So a lot of drag. So what they did is, if you want to overcome this drag, all right, then you will generate a lot of heat, which is, it might damage the whole lander system. So what they do is, because this drag is actually resisting your lander to coming back into the Earth. So what they did is, they use this drag force, okay, to push this lander out of the atmosphere. That means at 60 kilometer, it will jump out. Okay, jump up back into the space and then come back again. All right, so it will go back into the space and then coming back. So the advantage of doing this, that means go out and come back again, which is the kinetic energy over here, okay, can be changed, all right, can be reduced when they go out, because we know when they go out, change to potential energy, the changing energy, there are losses, okay, so there are losses. So when they come back, they can come back in a relatively lower velocity. So come back at a relatively lower velocity, that means they can ensure the safety and of the whole landing module. So this is something special about the landing trajectory. All right. So a better graphical approach is this one. All right. So come out about 60 kilometers above the sea level, it will go out again and then coming back. At the end, 10 kilometers above this sea level, they will deploy the parachute. Okay, deploying the parachute is actually the same as the usual one. They have this small parachute, pull the big parachute. And then before landing, they will remove the parachute for the landing. So this is some artist impression on this bow shot. So that's it from me. So maybe I pass the session to Dr. Chong. Is it okay?
Okay. Before that, David, you have anything to discuss with, to ask our live? Anything to ask live? David?
Oh yeah. Actually, what is so special about this video? Like, why do they need to bring the moon sample back to Earth?
All right. For this moon sample back, one of the explanation given is from that they can understand, or they can use it to study and understand the formation of moon and the history of this formation of solar system. This is the explanation, one of the explanation given by them. And also by studying this rock samples of this moon, they can actually better understanding whether what is having on the moon and then what they want to do, or what will in future, what mission they can create on the moon. Also understanding the rock mission, they can, because the third stage of the whole lunar exploration project is actually staying on moon for a long term. That means for a longer period, 就是长期住在月球. So to stay on the moon for a longer period, they have to think whether the soil is suitable for agriculture or whatever, because they have to sustain themselves on this moon. So getting the rock sample, they can do some experiment on this agriculture part, on the biology part as well.
Yeah. Can, okay, so I present, right?
Yeah.
I present, okay. David, you can ask me question also later. Okay, welcome. Okay. Share screen. Wait a minute. No. No. Yes. Can you see the picture?
Yes.
Can you hear my sound, my voice? Can,
Yeah.
Okay, so just basically, I think our Lai has explained most of it. All right, very well done, Lai. I just add on to what you say, lah. So just to do it, I was up at 4:30 a.m. My alarm clock went off a bit late. I missed the launching by 2 minutes. So I saw, wow, it already launched successfully. So the launch was successful. 4:30 a.m. this morning, Malaysian time. Okay, 24th of November. So basically, this is our Chang'e 5, Long March 5, what they call rocket, Chang'e 5 rocket, on the way from the assembly building to the launch pad. All right. So it'll take 2 hours traveling slowly from the assembly building to the launch pad. See how small are the people? The U so small. So like I said, so you have the booster. I just want to add on. So basically, the first stage you have attached on the 4 boosters, and the 4 boosters are actually kerosene and liquid oxygen. right? The rest, the first stage and the second stage are liquid hydrogen, liquid oxygen, very cool. But the boosters are kerosene and liquid oxygen. So basically, like what I said, the exhaust from this long march 5 rocket is environmental friendly. That's why they launch it here. Wait a minute. So they launch it from Hainan here, down there. You can see Hainan, because in Hainan, it's closer to the equator, so they have the free energy of the Earth's rotational energy, right? So launching from Hainan as compared to the Shenzhou one is in Gansu, in the Gobi Desert, further up north, so you don't have that much rotational energy of the Earth. So you need more energy in the rocket to go up into space. But in Hainan is easier, south. But because previously in the Shenzhou, what they call rockets, they use like what I said, nitrogen tetroxide and UDMH, unsymmetrical dimethyl hydrazine, very toxic. So they cannot launch it in Hainan with this nitrogen tetroxide and UDMH. Because if they launch all the fuels come out, the people watching, they would be what they call poisoned by the gas. But in Hainan, they launch with this law. See? They launch it. So what comes out is what? Water vapor and kerosene. Burning kerosene is safe, all right? So that's it. So now, as what we know is, it's now on the way to the moon. So mark your date, 23rd or 24th of November, launch this morning. 25th of November, Friday, reach the moon. 3 days to go to the moon. Friday, reach the moon. And when they land on the moon, immediately, they will stay they will go to this place called, I'll just give more detail. This is a moon map. So in this place called Oceanus Procellarium, the Sea of Storm. And right above there, northeast western corner, is what our light stage is down Mons Rumke, a mountain there. I show you now. There. This is a mountain here, 70 kilometers wide, but not exactly here. A bit to the northeast, in the flat area of the lunar surface, they're going to land, right? There. And then because then on the 27th of November, Friday, the sun is just going to come up over here. Right now, this part of the moon where they're going to land is still in full shadow. Full shadow of what? The moon is blocking the light from the sun, the moon night. So all dark now. But on 27th of November, when Chang'e 5 lander arrived there, then the first daylight will hit the surface. And we know that one day of the moon is 14 days on the Earth. One night of the moon is 14 days on the Earth. So one whole day and night on the moon is 28 days on the Earth. So in other words, so when you arrive on 27, it will be totally dark, and then you will straight away light will come up slowly, and you will land there. So that means the Chang'e 5, the lander have one whole lunar day, 14 days, 2 weeks to explore, right? Because the Chang'e 5 lander do not have the radioisotope thermoelectric heater, right? Remember now Chang'e 3 is on the far side of the moon, no? And if you have at that moon night there, it's very cold, Remember, on the moon's daytime surface, temperature can reach about 120 degrees Celsius, hotter than boiling water. On the moon, at night on the moon, the whole moon night, the temperature can drop to minus 133 degrees Celsius. But very cold. So that's why they have to land here just when the sun comes out. So we have 14 days to explore the moon, because at the moon night, let's say another 14 days later, moon night, the temperature will drop to minus 130 degrees Celsius, very cold. And on this Chang'e 5 lander, there's no heater, no radioactive thermoelectric heater. So that's why they have to finish the thing in one lunar day, all right? So that means they're going to finish the project in one lunar day to get the moon soil and other data, and it will come back to the Earth on December 16 or December 17, right? So the whole mission from launching to go to the moon and come back to the Earth is about 23 Earth days, 20 Earth days, okay? So now more information. So this is the Mons Rumke. Now, why do they want to choose the Mons Rumke? Because from what they understand is, the lunar rocks brought back to the Earth by the Apollo mission. Apollo mission, it seems 6 missions, Apollo 11 to Apollo 17, brought back about 382 kilograms of moon rock. All right, but the Russian brought back about 170 grams of moon rock. So American got 6 missions with human being, brought back the moon rock. Russian with 3 robotic missions, brought back 170 grams. So they are studying most of the moon rocks they found is from areas of the moon which are very old, 3 billion to 4 billion years old. So they already have done a lot of data of this area of the moon where Mount Sri is. It seems the area here, the moon material is younger, 1 billion or 2 billion years old. That's why they're interested to go here. So they're going to land not here, somewhere up to the northeast of the Mount Sri. So now we look at the whole thing again. So like what I said in English, I say now you have the service module, which is we push the whole rocket. Now remember, the whole long March 5 rocket plus the Chang'e 5 is 860 ton metric ton. If we say 1 ton is 1 proton vira, 862 proton vira. That's a lot. But the the service module, return vehicle, lander, and ascent unit is about 8.2 tons, about 8 cars, 8 proton vira. All right. So this service module will push the whole Chang'e 5 mission rocket from the second, detach from the second stage and push it towards the moon. And when you go to the moon, it is the return vehicle, the lander, and the ascent unit which will land on the moon. And later on, after all the mission objective done, collected the moon soil, put into the lander. So basically, the lander, all right, the return vehicle and ascent unit will blast off, all right. But the service module, of course, will keep on orbiting the moon. So when it blasts off, the ascent unit, I made a mistake. So lander and the return vehicle will land on the moon. But after that, the ascent unit will blast off on the moon. The lander here will remain on the moon. So the lander will have the sample, the ascent unit will join with the service module orbiting around the moon and come back to the Earth. You can see the detail like this. So this is launching. So right now it's launched from Hainan yesterday. It made half orbit around the Earth in space, and now it's on the way somewhere here. In 3 days, it will go to the moon. And as you see, not so easy, because they need to have tracking. China is a big country, but not a big country like Russia. So what they have is they have radio tracking station all over the world. So they have sent to China, they have their Yuan-1-3 tracking ship to some of the remote ocean to track. And the Chinese also, they have built their own in Argentina, in the Patagonian, very cold area, in the very cold area there, tracking station. All right, so they can track it. So that because now, if China cannot see the rocket, but Argentina can see. And they also have the collaboration China with ESA, European Space Agency. So European Space Agency have 2 tracking stations. One is in Kourou, in South America, all right, and then another one in Spain, Mas Palomas station. And of course, in China, they have. So in this case, the China can cover 24 hours what's happening to the Chang'e spaceship as it goes towards this moon. All right. So like this. So now, now we go to most important is now this is the simulation is the ascender is going up and the lander remains on the moon. But before that, there's a kind of a drill which you drill to the moon surface, all right, and it's called a coring drill. You go down about 2 meters, and from the top of the surface down to 2 meters, the whole amount is taken out. About 2 kilograms or more of the lunar material is put into a container, all right. And at the same time, there's a robotic arm will come out, and there's a scoop also. So they will also scoop some surface material from the moon surface and put it in the container also. So in the container will be the lunar material from the surface down to 2 meters deep, and also the scoop material from the moon surface put inside. All right, and because we know that they don't have that many experiments on this Chang'e 4 as compared to Chang'e 3 lah. But here they have also have the radar penetrating radar. You can penetrate to the lunar soil even deeper than 10 meters and can see the condition below the surface, right? And a few other instruments like magnetometer to measure the magnetic field and also spectrometer. So this will blast back and it will come back to the Earth here. I just want to add on what Lai has said just now. So basically, remember to leave the influence of the Earth, the Chang'e 5 must achieve a speed of 11.2 kilometers per second. So when it comes back to the Earth, it will come back at also 11.2 kilometers. So it has to reduce the velocity. So it's called the skip return. You have to go down into the lower part of the Earth's atmosphere to bleed off the velocity, reduce the velocity, go up, and second time. If it come all one time, the stresses on the rocket will be tremendous, G forces, very high G forces, and temperature of the heat shield is very high, very dangerous for the rocket. So it will have to go down first to reduce the velocity, go up and come down the shape. And I think this is also, they have actually remember in 2014, China launched their Chang'e 5T1 mission, 2014, 6 years ago. So it's exactly the same mission as Chang'e 5 today, but they launched 6 years ago without any intention to land. So what is it? The launch from China in 2014, the Chang'e 5T1 mission, which went around the moon, and this time there's no retro rocket firing to enter into moon's orbit. You use the slingshot effect of the moon to push the rocket back to the Earth, and then it land to the Earth with the skip return. So they tested it 6 years ago. It's safe, so it's good lah. So eventually it will end like this, like this. Now this is not the Shenzhou. It looks a bit like Shenzhou. You see, human beings is much a human being cannot go inside. This is where the moon rocks will be contained when it enter the Earth's atmosphere, and hope it will land successfully. So where will it land? All right, it will land somewhere in Inner Mongolia. So we have in China, you have the Neimonggu, Inner Mongolia, and quite a bit of desert flatland there. Not many people inhabiting there. Called the CC1 banner. Right? They use a banner system in Mongolia. So there they're going to land. So in a sense, if you look at the Inner Mongolia, so China have a problem, you know. The Americans, they will land a lot of the cases in the open ocean, a lot of place to land, right? But the Russians will launch in what? Kazakhstan. Kazakhstan is a huge place, you know, much bigger. I think Kazakhstan itself may be as big as Xinjiang. So a lot of place to land. But China had to find a place in Inner Mongolia. So that means when they re-enter and land in the CC1 banner in Mongolia, they have not much space to have a mistake, all right? But hopefully it will be successful. So we are all waiting for 16 or 17 of December for the return, right? So 2 kilograms of moon rocks is a lot, you know. So some of you may say, well, what's so special about moon rocks? Remember, the scientists are so clever that you just say, I scrape from a certain asteroid, 1 gram of the material from asteroid and take it back to the laboratory on Earth and study it. They can get 101 information about the asteroid. So definitely they're going to see a lot. So already, you saw in the news the past few weeks that they say that the material on this Oceanus Procellarum, Sea of Storms, is younger, 1 to 2 billion years old. So they suspect that the data they can get by analyzing the moon rock and moon soil from this area will rewrite the history of the moon. There mean a lot of things on moon we don't know will be answered by this moon rock. So we are all so excited. But the problem is this, that's it. The Chinese now are going to attempt many first, you know. All right. Earlier, of course, you have Chang'e 3 landed on the moon. But now the thing is, they're going to have a what they call orbit around the moon. They have done before, but first time land on the moon with and get this. No, not really land on the moon. They have detached before they land. The lander and the survey module will detach. This is the first time. Previously, it was not attempted by China. So this is the first time they did the lander and this service module will detect, and the lander will land automatically, right? And then they will get the soil from the moon, the rocks from the moon, and go back and join with the automatic robotic docking with the service module. This is never attempted before. So actually China is attempting a lot. Plus also final re-entry back to the Earth with the lunar sampler. Never attempted before. So in other words, China is trying to do a lot of things all in one go. No? So we hope it will be successful. Right? The moon rocks. And already we saw in the comment by some of the young Chinese students, high school students, that they are interested to do space exploration. So exciting, you know. Right? Huh? I think that's about all. Huh? So we now wait until, okay, the next critical stage is what? Retro fire to enter into the moon's orbit. So basically now, it will take about 3 days to travel from the Earth to the moon. And when you reach the moon, you have to flip the direction of the rocket such that the front of the rocket is facing away, the back of the rocket is facing this way, and the rocket will fire. So you know why? Because the velocity of the rocket leaving the Earth is very fast, you know. So if they don't have a retro fire on the rocket when you reach the moon, the Chang'e rocket will fly by the moon and never come back. So you have to slow down the rocket. You have a retro rocket fire to brake and brake. Then only you have enough velocity. Then it seems when it goes into moon orbit, it's not easy, you know. The first moon orbit will be highly elliptical, all right, near the moon and power down a big ellipse. Then later on, you have to keep a few firing of the rocket on the lander to circularize the orbit, so that to make the orbit circular around the moon, then only they can land on the moon, all right, like this. So all this is very, very new thing, you know. So all these are the first for China. So we hope it will work, all right. So now the next part is, after landing on the moon, of course, we hope that, now remember there's no rover, no U2, no U2 rover. It's just that there's an arm will go and scoop the lunar material, put in a container, and also a drill also. We drill, get the cores, all right? That's all only. There's not many experiments. But the next important thing is blast off from the moon and go and dock with the service module orbiting around the moon. That is very, very critical. That's the thing. And after that, what happened? Fire the main rocket of the service module coming back to the Earth. There's another critical part. Let's hope it works. And the final thing is re-entry into the Earth's atmosphere over Inner Mongolia and land on the Inner Mongolian desert successfully. That itself is a big thing. So we hope all this will be done successfully. So we all wait for 16, 17 of December for Chang'e 5, the thing to land. So basically what will come back is this one. No. Sorry, this one. Right? The small one, you know. So the Shenzhou module is much bigger because you have 3 Chinese taikonaut going inside. This is the smaller version. So this module where the moon rocks will come back is exactly the same shape as the Shenzhou module, but it's much smaller because there are no human beings, right? So it will come back, and we hope that it will land successfully, right? So okay, I think that's about all. Any question?
I think if our audience have questions, they can put it in the comment section of the live session in the Facebook. We accept questions in any languages. Not any languages, but in either it's okay for English, Chinese, or Malay. All right, we can answer the question. All right.
I have a question.
Can please.
Yes.
Of course, this launch is very interesting. The launch, the lunar insertion orbit, the circularization, and finally going down to land, going back up to dock with the service module and going back to Earth.
Not dock only, you know, David. Automatic docking. Never been attempted before. Apollo is human being docked with the command module and so on. This is all robotic docking, you know. Very, very interesting. Yeah.
What I really want to know is that where will it re-enter the Earth's atmosphere? Because of course the other things are very exciting, but I cannot really see it with my own eye. It will be really nice if the Chang'e 5 fly over my house, will it re-enter? Will that be possible?
Yeah, actually, Actually, okay, let me see. Let me post. Sorry. I'll post now. You can see, this orbit. Okay. So basically, you know that when they come back to Earth's orbit, they always try to economize the fuel, use the minimum fuel. So when they enter into the Earth, the uppermost part of the orbit, remember, it's going to land back finally in Sisiwang Banner in Inner Mongolia, just north of Beijing. I think about 100 or 200 kilometers north of Beijing. So it's going to go, go vertically and drop, It's going to like this, It's actually, wait, half a world away. So imagine this is China. The other side is where? Maybe it's Texas somewhere in North or South America. You start enter the Earth's orbit. It will enter. They will use the word Hohmann's orbit. Hohmann's orbit means half the Earth before it will enter the Earth's atmosphere, and you slowly enter, and later enter into the deeper part of the atmosphere, and then you have the skip re-entry. So when the first entry go down to bleed up a lot of velocity, then it goes up and it go down. But sorry, if you see carefully, David, if it's going to come in the movie, either it's going to come from what they call, most likely it's going to come from left, from the lower left to the upper right. It cannot come from the upper right to the lower left. Cannot. It must be from the lower right to the upper left. And you see what is on this side is what? India. Tibet is what? India. So it will not pass over Malaysia. It will not pass over Malaysia.
Pakistan.
Pakistan, India, Pakistan, definitely. You can see lah. That's it lah. Yeah. So it's very interesting,
Yeah.
So any question on the people ask? I just
while we're waiting for our audience to post their questions in the comment section, if they have any, I just want to add on a little bit lah. So maybe many people will wonder why, because CCTV spend a lot of effort doing this live session, but then it's a midnight launch or early morning launch at 4:30 a.m. Why they are launching at this time? And why they spend so much effort on this. Of course, we can understand that because at this time, this is the 5th launch, and then they are breaking a lot of record for this mission. They are trying many of their first time in this mission, so they are very excited on this one. But then since they are doing live broadcast, so many people are keen to watch this. Why they do it at 4:30 a.m. Instead of why they don't delay it to later, maybe 6 o'clock or 7 o'clock, where more people are awake and no need to stay for so long or the whole night to wait for the launch. Actually, there are a few reasons. Okay, in fact, the window they release is they announce is actually 4:10 to 5 p.m. It's a 15-minute window. In fact, if you look at the whole night, actually, the whole night actually from 3 a.m. the window actually start at 3 a.m. and for launching in today, okay, the window actually ends at 7 a.m. So that means it's a 4-hour window it's a quite long window. But then why they are doing at 4:30 a.m. there are a few reasons. So the first reason is of course using launching at 4:30 a.m. That means 4:30 in the morning for the orbiter design. And this is somehow based on their calculation, this is the most efficient and the most simplest orbit launching at this time. So just to add on a bit on this consideration, how they design this orbit, that means the Earth-Moon transfer orbit, there are a few things they need to consider in the calculation. So include the position of Earth and Moon, and also the time that they want the spacecraft to travel, or the whole Chang'e 5 can travel, how long it can travel. And these are the two main considerations when they design the orbit. Of course, we know the most efficient way is using Hohmann transfer, right? But then knowing the way of transfer is not enough. You still need to consider the time, the space, the position. So 4:30 they found out is the best, the simplest one. Because of course we know that we just see, oh, they launch and then we're happy, we glad they announce the launching is very successful. The Chang'e 5 have go into the desired orbit, and then the boss come out and announce, and then everyone happy, clap, take photo, and the session ends, the live session ends. But in fact, after they announce this, and then the flight control center in Beijing will take over the control. All right. So there are a few, they call it orbital corrections. That means there are a few maneuvers performed when this Chang'e 5 is flying to moon. Generally, we know is Hohmann transfer, a very effective way of transfer. But to perform this Hohmann transfer during the flight of this Hohmann transfer, okay, there are actually some maneuvers. Some maneuvers have been conducted, or some command sending from the ground station to this Chang'e 5 to perform some maneuver to make sure that this Chang'e 5 fly correctly on the desired Hohmann transfer path. And the second one is something they want to avoid, because something difficult to predict is this solar activity. Of course, we know 2020, last year, starting from last year, 2019, this year, 2020, is the solar minimum period, which means the sun is very less active. For the whole year, we only see 1 or 2 sunspots for the whole year, which means that the sun is very quiet. But then you don't know what and when the sun will be suddenly active, or whether there will be suddenly a prominence of solar wind. So when you have solar wind, they will have this effect on this communication system. This is what they want to avoid. So launching at this time, all right, based on their calculation, they can actually use the Earth, the whole Earth, as the barrier. It means if, let's say, so unfortunately, during the flight, suddenly there is this solar wind coming to Earth, right? And then the Earth will act as a very good barrier to protect the Chang'e 5 from all this solar wind, so that less effect from the solar activity. So this is the second reason. And then for the time-wise, 4:30 a.m., another thing is, if you study the weather, the meteorological study, they realize that at this time, the sky is relatively, or the weather is relatively stable. All right, less clouds, or less clouds, it means thinner clouds, all right, which is even better for tracking. And it's more stable. You won't suddenly have, you have a clear sky and suddenly you have this thunderstorm. No, it won't happen during this time, especially at midnight. So they say the weather is relatively stable based on their statistical data. And another reason launching at night is easier for observation. That means optical observation. If you're at Hainan, you might see they set up their telescope to watch the launch, because not everyone can go near to the launch site. Only people with specific permit or those press permit, they can go into the launch site to take live video or to cover for live session. Many amateurs, they are keen, but then they don't get the chance to go there. So they will stay where they stay. They will stay hotel nearby. So there's some news or some data shows that actually the hotel nearby this launch site, the price go up 5 times compared to normal time. So it hikes. Every time when there's a launch, the price of the hotel per night will go maximum. They said there are some hotel go up to 5 times the normal price. So actually this hotel, somehow this launch actually brought up the economic, the tourism industry in Hainan.
Astrotourism.
Astrotourism. This is a typical example of astrotourism. And also, so many of these people, they cannot go very near the launch site. So they will stay a few kilometers outside the launch session. So they will set up their optical telescope or binoculars to observe the launch, and it's a better observation for them at night, because daytime, after the launch, maybe during the launch, the few seconds you can watch, but as the rockets go up towards the sun, you cannot look directly into the sun through your binoculars. It's very dangerous. So this is one of the consideration from the space agency as well. And of course, one advantageous is if they launch at night, and especially currently it's winter, so nighttime the temperature is lower, so it's better for the payload in the rocket itself, because when they take off, as they go faster, the what we call the head of the rocket will getting heated up by this airflow, aerodynamic heat. Aerodynamic heat is no joke. When you travel faster, more and more heat is generated. So during this time at night, the temperature is lower, so relatively there's some cooling effect. It's just an add-on point for launching at night. So this is why they decide to launch at 4:30 a.m. instead of why not later.
Of course, as usual, the flight path of Chang'e 5 is over the South China Sea, north of Philippines and south of Taiwan. I'm sure all the aeroplane flight and ships traveling on the sea, they would have been warned also. They should have been warned also. Yeah.
Yes.
I just want to add on one more thing. So basically like this. Okay, we go back here again. Okay, so now the Chang'e is left the Earth going towards the what do you call this, moon. It's not fully left the Earth. Yes, left at if you leave the Earth at 11.2 kilometers per second, exactly equal to the escape velocity, it may not go to the moon that fast, It may go somewhere halfway to the moon and come back to the Earth, So it may be faster than 11.2 kilometers per second. So now, once it's on the coasting stage, free fall stage, the engine is not firing anymore. Quietly, it's going to the moon. And what happens is, as it goes toward the moon, the Earth gravity will pull on the rocket, so the rocket is getting slower and slower and slower and slower. Slower and slower and slower. If the moon is not there, a time will come, it's so slow, it will come back to the Earth. But because it will come quite close to the moon, then the moon gravity will pull and take over. Then the moon gravity will attract the Chang'e rocket and it will enter into moon's orbit. But in between, I think there should be one or two mid-course correction, isn't it? When
more than two.
More than two, because not always the same. So you have the side thruster, to change the parameters slightly, so they enter the Earth and the moon, the first orbit, the long ellipse at the exact direction and velocity. So not easy. So everything must be calculated. Remember, in any space program, they are the theoretician. They are what? Applied mathematician. The old name is what? Celestial mechanician. The new name is what? Astrodynamicist. So they apply, like what I say, Newton's law of gravity, not the general theory of relativity, Newton's law of gravity, and they make all the calculation with the supercomputer, and you see which is the best orbit. So everything has been done already. So this celestial mechanician, very important, no? They calculate the exact orbit, hopefully using the least amount of fuel and so on. Okay.
Just to add on, so similar to the Mars mission, actually when they go near the moon, they will have a so-called brake They will brake to slow down the spacecraft. Similar the previous Tianwen mission also, when they go near the Mars, now they are going at the almost constant speed, which is at the slightly greater than the escape velocity of Earth. That means to escape from the Earth gravity. But when they near Mars, they have to brake until what is the velocity, which should be slightly lower than the escape velocity of the planet or of the celestial body. So for this case, they should go slightly lower than 2 kilometers, around 2 kilometers per second, because this moon's escape velocity is about 2.4 kilometers per second. So they should go slightly lower than that, so that they can be caught by this this gravity of the moon and go into the moon orbit correctly. Right. So this braking is a very important maneuver when they go near the moon or go near Mars or whatever planets. But the story is different for Jupiter or Saturn because they are bigger in size and they are heavier than Earth. So their escape velocity is larger than Earth. So they do not need to brake for if they are going to Jupiter or they go to Saturn.
So I saw in this morning before the launch, there's one Indian guy following the launch, his website is in English, So he's very impressed by the China space program. And there was a Masari, I think he's from America. So I think a lot of people in the world now are following closely the China space program. And then I know what they say, wow, if this Chang'e 5 bring back the moon rocks, already the China National Space Agency already lined up Chang'e 6, Chang'e 7, Chang'e 8, Chang'e 9 already lined up already. So you'll be very excited.
For their plan, for what I read previously is they have until Chang'e 6.
Yes.
But currently, if this Chang'e 5 success, the Chang'e 6 maybe no more because this is previously the mission is not so complicated. Previously the mission is slightly simple, is just collect some sample and come back. Of course, the system is more simple, but this time they are breaking a lot of record. They break through a lot of this technical barrier, so they try many new things. So if this time success, maybe for Chang'e 6, they will go for other mission. It might proceed to the second stage, which is no longer unmanned mission. Like the human mission.
We already know that the further stage is they are going to set up a lunar research robotic station on the moon, and later on, of course, man on the moon. But China man on the moon is 2030s, more than 10 years from today, right?
Yes.
Of course, the whole thing is because Apollo already landed on the moon. Nothing so new to land on the moon. So what is the new on the moon? Permanent human base station on the moon. That is what they want to do. And already...
Yes, that is the third stage. So they will stay on the moon for a certain period, for a longer period.
Yeah. And already yesterday, they interviewed the China Corporation scientist, Yang Yuguan. He always speak what you call explain one. He always said that one of the mission objectives of China to go to the moon is they want to harvest the helium-3. Remember, the solar wind from the sun hits the moon for billions of years, and on a thin layer or on the moon surface or all over the moon, helium-3. So helium-3 is a type of isotope, rare isotope that very hard to produce on the Earth. But helium-3 is very important to have nuclear fusion. Remember, the Europeans and the world scientists are building the ITER tokamak fusion reactor in south of France, Cadarache. And if they have this helium-3, then it's easier. So one of the main reasons humanity goes to the moon is to harvest the helium-3 and bring back to Earth. Then we can use, because so much helium-3 on the moon, it's a kind of catalyst. Then we can, and of course, the most important part of the fusion reactor is heavy water deuterium, which is found in where? Water in the ocean. So the fuel is from the ocean of the Earth. Helium-3, the catalyst from the moon. So mankind, what you call energy requirement will be solved forever. Bye-bye Saudi Arabia, bye-bye oil. And that's what they're thinking of in the long term. Yeah. So we hope the re-entry Earth into moon's orbit is successful 3 days from now.
There are one question from our audience.
Yes.
Asking, for the hopping re-entry style, is there the more the hopping, the lesser the effect on spacecraft?
I can answer if you allow me. Of course, now it's one deep hop and then go up into so that you can see the website. It's entering the Earth at 110 kilometers. The first skip enter is down to 60 kilometers from the Earth's surface. And then you point up and go up into outer space above 100 kilometers and come down again. So it's like one hop, go up, and second hop reach. Of course, the more hop, the better lah. The more thing, but see, the more chance for error. The range, you are talking about the range, if you hop once, the range is smaller. You can arrive at your destination more accurate. You hop many times, more error. Because when you have this thing that is hopping, there is no more thruster, no more rocket firing in the rocket, It's all like falling the stone, All right? So it's like aerodynamic shape, will guide where you're going to land. So if you are more hopping, the danger is that the range, the error in the range will be affected a lot. So it may not land in Inner Mongolia, it may end in the Yellow Sea, or then land on Korea. You see, like this. So basically, just enough for them to bleed off the energy, the skip go up and down again, just enough to land in CC1 banner. All right. So now we know, hundreds of millions of the Chinese people, especially the young Chinese, are watching. They are talking.
Yes.
And they are not talking in the research institute, no, in the coffee shop, eating the rice noodle, eating their char kway teow, their noodle. Yeah. But now the problem is, will they come back and give to the Americans 1 gram? 1 gram. Yeah. It'll be very interesting. So we hope the China government will see the sense. They can bring along some of the moon rocks, not to give to Malaysia, hopefully give in better exhibition in Malaysia. 1969, Apollo 11 landed on the moon, I remember 6 months later, in the Museum Negara in KL, there was a big exhibition where tens of thousands of people queue up just to see a small piece of rock, moon rock from the moon. And then when I saw the moon rock, I thought I think it's about smaller than 1 cm size, and it's enclosed in a glass ball. So everyone have a chance to look at it for about 5 seconds only. Next. So I hope they will bring the moon rock and exhibit around the world. Yeah. But I think in Beihang Museum you can see bigger pieces. Bigger pieces.
Hopefully, hopefully. We have to talk to the boss first.
Yeah.
Yeah, but then
also can get a bit.
Yeah.
I think kind of, because we are the same, we are under the same department.
Yeah, can. Maybe some of those top secret projects also, a lot of top secret project, military project. Yeah. So, but you see, if you look at many of not even the earlier Apollo website, even the recent American website, they give a lot of technical information. For the Chinese website, I want to learn about the orbital dynamics. Not much information. They give you minimum. Sometimes the American one, they give you a lot of information. Very detailed. Yeah.
And yeah, because Chinese one, they have a lot new technology, and this new technology so far all are so-called secret technology for the time being.
Yes,
So they will not share for a short time unless they have something even more advanced, and then they will share you the old one. But currently, they will keep that for themselves. The next question is, what is the biggest challenge on this mission? So Dr. Chong, you want to start first?
You start. Why you answer?
For this biggest challenge, of course, we know there are a few so-called world record. So the first world record is this robotic docking, automated docking in moon. So we have a lot of docking. We have a lot of docking experience on since the development of aerospace or the space industry. Docking of ISS with the Soyuz and the ISS, or the supply spacecraft to the ISS also docking. And even the Apollo mission also is docking. But as Dr. Chong mentioned just now, is what we call the human docking. That means there are people inside and then doing this, what we call, doing this the docking mission, the docking maneuver. So this is the first time where everything is automated. All right. So this is one of the biggest challenge. Another biggest challenge for China itself is taking off from the moon surface, because taking off from moon surface is very difficult to be simulated on Earth. We can do numerical simulation. We can do with supercomputer. We can calculate a lot. We can put in many different conditions, and then we can calculate all the possible condition that we met. But in fact, we cannot carry out actual experiment with the gravity of the moon condition. And of course, we know that the moon the atmosphere is very thin and then it's quite calm, but we don't know whether what will happen during the in fact we have very limited knowledge on the weather on moon. To be honest, we know that this is how to say, we know that the condition theoretically, but then the fact, the actual one, how is it, we don't know. So this is another big challenge for China. And then the third one is for this landing and called the sample collecting, because previously the American, when they take back the soil sample or the rocks, the moon rocks, is human collect. So it's nicely packed and then they bring back. But this time it's all automated, and it's not pack and then transfer. Is they collect the soil and then bring up to the ascent unit. So it's not nicely packed yet. So in the ascent unit, it docked with the orbiter module, all right, which the lander, the Earth land, the return mission, the return module inside. So the sample, the soil sample will be transferred into the return module in air, and then only over there they will nicely seal the thing automatically, and then only they will come back. So this is another big challenge. So this is three main big challenge. Of course, there are many more. If you all can have a better, a more comprehensive discussion on a lot of online information, more comprehensive one. So anyone want to add on?
I got 2 points, right? I got 2 points. One is another big challenge is what? The money, enough money budget or not. So a big budget, no, to go to the moon. But we know that I know, you know that China has been learning a lot of problems in developing their space technology. It's not easy, you know. Just to develop one part of the rocket, say the fuel, liquid oxygen, maybe one institute, you know, and many engineers, no. So you have tens of thousands of people, maybe hundreds of thousands of scientists, engineers. So it took a long time. But I think China now have built up a very good infrastructure, mostly there already. They just to come up with new idea. So, but the China budget is cannot compare with last time NASA. But we hope that the China, they will still invest enough money to do good exploration. Now the second point is very important. I totally forgot. Now I remember. Hey, when you land on the CG1 banner on the 17th of December, please look at the scientists opening it out. I have a feeling they will be wearing the hazmat suit. Hazmat suit is just a radioactive contamination or bacterial contamination. They wear the full hazmat suit. Like now we have the COVID in some hospital. So hazmat suit is outside them will not come in contaminate. Because we know that when the Americans brought the moon rocks back to the Earth, the first Apollo 11, 12, 14 mission, the astronauts are under quarantine, you know, I think for some weeks, because they say that the moon rocks they bring, maybe on the moon you have those dangerous sicknesses can bring back some toxic material. So under quarantine. So later on, the later mission no need quarantine. But I think the sample they brought back to the moon, they must be follow the United Nations Outer Space Treaty 1967 protocol. They are very specific, you know. So you bring back material, you go to the moon and bring back to Earth. What are your dangerous organism? You have seen a lot of terrible science fiction movie. Bring back to the Earth population wiped out. So they must follow very clean condition. Then I think in their clean room, everything must be fully controlled one, like a clean room. So make sure that no contamination. So it's very good. When they land on CC1 banner, if let's say they open up the hatch, you see whether they wear the hazmat suit. So we know when man wants to go and colonize the solar system, you go to the moon, you bring back the moon rocks to the Earth. No? So it's called backward contamination. Now, what about the lander of this Chang'e 5, Chang'e 4, and the American lander, and then the Russian lander is called forward contamination. So in other words, a lot of those spaceship, before they send to the other planet, land on planet, they actually put in a big furnace and bake it, high temperature, kill the bacteria. So, but they know that some of the very tough bacteria in the wire of the spacecraft cannot be killed, Very tough still there, You cannot kill all. But most of the bacteria, microorganism is killed. So there's no forward contamination to the moon by Chang'e 5 lander. And also they come back, bring back to Earth, hopefully no backward contamination. So they must follow the United Nations protocol. This one you didn't say. I'm very sure the institute, they said that the China National Institute of Astronomy will keep the sample. I'm sure they have a room which follow very strict protocol. One of them in in this type of bacteriological weapons lab is what? Outside pressure, inside the room pressure is less than 1 atmosphere. If there's a leak in the building, it's the air from outside going into the building. And that's the way. You cannot have the same pressure inside this building, studying the moon rock, and the same pressure outside. Or pressure inside more than pressure outside. In that case, there's a small leak in the window, the air with the dangerous organism from inside will leak out. So the outside pressure is 1 atmosphere, the inside is less than 1 atmosphere. Then it's safe. That's called bacteriological weapons lab. So I'm sure the Chinese they will follow this protocol. It'll be very interesting to know how they cut open the moon rocks and study them. Yeah. So like this,
that one we will have to wait and see after the return how they do. I believe there will be a lot of news on this.
Yeah. So can or not, ASP through Malaysia, it cannot from society to government. Government to government. We write a request, the amateur astronomers in Malaysia, to the Malaysian government, that we also want to study the moon rock. So we request Malaysian government to get some moon rock from China to come here with research. Not for ASP, the whole community. You can think about it, no? Remember, the American moon rocks are sent all over the world, no? For research all over the world. Big amount, small amount. Yeah. So remember, when the first time you see a moon rock, please don't touch it. Dangerous. Dangerous. Better wear your suit, wear your mask, everything. Dangerous. Any other question?
So far, no, from the comment section. So far, that's the question. So I think before we end, I just want to add on something, which is we're talking a lot about this technology, this technical information, but let's don't forget the people behind. So just a simple intro to introduce who is the big boss of this Chang'e 5 rocket, and also this what we call the Chang'e 5 mission. So this is the chief designer or the head engineer, the big boss.
Please post a picture.
Yeah, can see. I share screen.
I don't see. No share screen.
No.
Didn't share.
Got
it. Now yes.
Yeah.
Okay.
Yeah.
So this the one on the right. His name is Li Dong. Li Dong. All right. Good to introduce. Also, he's my senior. He graduated from Beihang. And the one on the left is actually Beihang Secretary of Party Committee. These party committees, they have this secretary inside the school. So this is our secretary, and this is Li Dong. So he's actually started study in Beihang in the year 1985.
Yeah.
In 1985. So this is him. He's the chief designer of this Chang'e 5. So Chang'e mission is him, the Chang'e 5 rocket. He's the chief designer. So a bit fair. Okay. But then, yeah, he put in a lot on the effort of this rocket.
I thought like the lady on the left is the lady that came to talk to you in Tech Dome. I thought
no. This lady is our school big boss. The university big boss. Yeah. So not only Li Dong, okay, the name or the person or the chief commander called Wang Yu is also from Beihang, graduated in the year 2009.
Yes.
And then the assistant or the second boss is also called Yang Hujun. Yang Hujun is also from Beihang. So basically, a lot of Beihang people inside this rocket. I believe a lot of Nanhang people inside rocket. Inside this mission also.
David, you have that, David?
if you look into your school web page, they will share lah. So this is about the rocket. And then this guy is called Yang Mengfei. Yang Mengfei is the chief designer of this Chang'e 5 mission. All right. He's from this called Xidian University, Xi'an 电子科技大学. Yeah. He's quite young, I think. He's quite young. Yeah. Born in the year 1962, and then he get his bachelor degree from Xidian in 1982. After that, he stayed there. Now he's the deputy dean. So he's the chief designer for this Chang'e 5 mission. So these are the two. These are the two most important person of this whole launch and the exploration mission. Of course, these two are most important. Behind them, there are a lot of engineers, a lot of university professors involved in this project. For example, we have this teacher, one of our Professor Dong Chaoyang from our school, also he involved in the rocket control.
You're so lucky, you're so lucky.
And then we have from material side also, from our university, the School of Material Engineering, they have professor involved in this rocket material because this rocket, they have this hydrogen and oxygen as the fuel, so the temperature is very high. So he researched on this rocket material so that it can sustain this high temperature to survive during the launch. So there are many people involved. They come in a team. He himself, even those professors also, they have a lot of postgrad students involved in this project. So that means there are many fresh blood or young blood involved in this national space project. So this is something actually I'm hoping the country can do, which is getting more and more young people involved in the space mission. Right? Not only those big people, those engineers involved, those those people sitting up there involved in the project, and at the end they will end up the project in just saying and nothing happened. End up nothing happened. You get some young engineers, young students from the universities. They have a lot of ideas. Involve them, and then you will move pretty fast. So I
just want to add one more point. If I'm correct, I check if I'm correct. I think the organization system in China is very interesting. You know, the main thing is of course the China National Space Agency, government control. But underneath you have certain CALT launch technology. Many of them like private or semi-private companies.
No, it's actually government control.
Oh, government control. But yes, the way it's done, it looks like a private company,
for this so-called national defense involved technology, you cannot privatize. They have actually like this. Previously, we have one we call the China Space X. I forgot the company name, but then it's a private company that launched rocket.
Because under the
there have a few successful launch, but then and because of this pandemic, unfortunately, they said the company bankrupt already because they cannot do anything.
Under the CNSA, there are many huge groups, CALT, many of them. I thought they are like semi-private, commercial, or government. And then they are huge organization, thousands of engineers and scientists, Yeah.
Yes. You remember, I think 2 years back when this Miss Zhou come from this China, she's from Kasich.
Yeah.
That day I managed to chat with her, I think last year, because their company make a tour. They have a group of people coming to visit our museum. So I did not accept that tour. I did not bring that group. But then I messaged her. I asked whether is she joining the group. She said in her company she have about 10,000 employees. So 10,000 people working on this company, on this space thing. And this is only one of the company. And there are a few companies for this. That means a few 10 or 100,000 of people are actually working on this space project.
Lai, can you allow me to present? I want to present one picture and then we stop. Okay. Thanks for waiting. What do you call Jin Chong, thanks for waiting. There's one more picture. You can see the map of China, huh? Can, huh?
Yeah.
Okay, so basically like this. Why they build this Wenchang Satellite Launch Center? Because near the sea, near the south, better lah. But previously, the China launched all inland because under the Cold War time, if you launch near the sea, all the spy ship outside can spy. But now no problem lah. Another thing is this. Because they are now build the Long March 5 and many of the rocket launch in Wenchang, they are built in Tianjin, you know. Tianjin is near to Beijing, very near to the sea. So for Tianjin, they will put the rocket onto the ship. The ship will take the rocket to Hainan Island. Easier. The problem like that. Previously, when they launched from this what they call Yuquan and Xichang Launch Center, many of the Long March 3 and so on, the diameter of rocket is 3 meters. Only 3 meters cannot exceed. Why?
3.35.
3.35. Because if we put it in the big lorry or train and put it in the tunnel, through the tunnel size can take only 3.3 meter diameter. So it cannot go more than 3 meters. Long March 5 diameter is 5 meters. So if you want to make the rocket all over China, you cannot transfer on the rail system. All the tunnel cannot fit. That's why the 5 meter diameter Long March 5 can put on the ship and travel to Hainan. You can do that. Then only it's possible. So there are a lot of factors involved. Very interesting detail for me. I think it's good enough for me already. Live the explanation.
Yeah. So
Yes,
I think we don't have much questions on the comment session. So I think I hand it back to David.
Yes, David, back to you.
Okay, so thank you everyone for joining today's post-launch coverage session. If you manage to miss the front section or any sections, the video will be uploaded on YouTube soon. Or if your friend missed, you can also send them the YouTube video link. So thank you for joining us, and hope to see you soon whenever we are doing this again lah.
Yeah. One more thing, David. What do you think? If the blast off from the moon to come back to the Earth is successful, do you want to cover that? And re-entry to the Earth, 17th of December. Want to follow that?
That should be very interesting.
Yeah.
We end the session first and then we discuss this.
All right.
We end the session first. Chin Tiong, so the session end already?
Not yet. Now we are still live. If you are,
can end the session and then we are done. We can stop the session and then only we continue discussing.
Yeah.
Okay, sure. Right.
Thank you,
Thank you everyone for joining us.
So thank you everyone. Have a nice day. Good night.
Tomorrow morning, the meeting. Don't forget. Okay.
Okay, sure.
Okay.